Okay, question number 2. So, Saira is coasting on a roller skates at a constant velocity of 20 meter per second to the right when she collides head on with Jane, who is standing nearby. Okay, this is an SL, HL question. Okay, there is nothing purely on HL. So, both the questions you can ask. So, after the collision, the two girls move away, tangled together with the same velocity. Let me write down the diagram. I always prefer to write diagrams. This is Saira, and this is Jane, and who is standing nearby. What does it tells you? That this is moving at 20 meter per second, and she is now standing with a velocity of 0 meter per second, and there is a collision. And after collision, what happens? Both of them get tangled, and S and J, they start moving with the same velocity. And then it also states Tyra is 40 kg and Jane is 60 kg. Let me write this as M1. Let me write this as M2. Okay. Here the principle of conservation of momentum. What does conservation of momentum tells you? It tells you that uh, total momentum before collision is equal to total momentum after collision if no external forces act on the system. Most of them write only this part, but remember that this is very, very important, and if you don't mention this, then your statement becomes completely incorrect. Okay, next, determine the final velocity of the Saira and Jane. So what we should do, so first write down what is the momentum before collision for Saira and Jane. For the first one, for Saira, it is what is the mass? 40 multiplied by 20 plus what is her momentum? Jane's momentum was 0, because though she has a mass, she is not moving. 60 into 0 should be equal to, both of them had joined together entangled, so which will be 40 plus 60 is the total mass, which will be 100 multiplied by the velocity. So what will be this now? 40 into 20 would be 800, would be equal to 100 V, or the combined velocity V will now be equal to this double zero goes, becomes 8 meter per second. This is the answer. Calculate the change in kinetic energy of the system. So what you should do? Very simple. So you should just calculate what is the kinetic energy before collision, and then calculate the kinetic energy after collision, and then find out, okay, what is the difference between them, because this is change. Okay. So therefore, kinetic energy before collision, I'll write this as kinetic energy initial, which will now be equal to half into 40 multiplied by 20 square, because this does not have any kinetic energy, because V square is 0 here. This will be equal to how much? It will be 20 into 20 cube. 20 square, which will just be equal to 20 cube. I have not calculated, I just put it like this. Then kinetic energy final. What is the value of this? Kinetic energy of the final would be half multiplied by what is the total mass? Both of them are moving the same velocity, right? It will be 100 multiplied by V square is 8 square. This will now be equal to 2 ones are 2 50s are, which would be 50 multiplied by 8 square. So that's what I get. And maybe I'll write this 50 into 8 square is 64. Now what do I need? I need the differences. Differences delta kinetic energy will now be 20 cube. 20 cube would be 2 cube into 10 cube, which would be 8 into 10 cube, and minus, what is this now? It is 50 into 64, would be, I'll put a 0 here, 5 4s are 22, 5 6 30, 3200. Now this will be 8000, this will be 3200. Difference between them, initial minus final, would now be equal to 4800, right? 4800, 5000, 8000, 4800 joules. In fact, this should be negative, which means I should have taken final minus initial, which means there is an energy loss. Okay, so change in kinetic energy only is asked. He is not asked about what is this, there energy lost or anything. So therefore, I took kinetic energy minus initial minus final over here. Okay, explain whether the collision is elastic or inelastic. Definitely, it is inelastic. It is inelastic. Why do I say it's inelastic? Because it's asking about explain over here. So when I say the combined term is explained and it is 2 over here, then you should say it's inelastic because your change in kinetic energy is not equal to 0, but it is negative. How do I know negative? Because you should have calculated delta kinetic energy is equal to kinetic energy final minus kinetic energy initial, which is seen to be minus 4800 joules. So this is an inelastic solution. And again, you can also reason one more, because both the both the both the objects, maybe you can say both the persons, okay, are moving together. You can mention this also. Okay, so thus we have completed all the four parts of the question, okay, using this method. This question was seen to be much more a straightforward one than something like more complex. Okay, so this qualifies very much for an SL.